right, so let's review for the Chapter 7 test for stats. So what we are going to be looking at are all the different things that we've learned in Chapter 7 so far, which is basic probability. And so just so you remember that a decimal can be written as a percentage if we multiply it by 100. So we just need to be careful as we go between these, because if you tell me 0.05% when you meant to say 5%, your answer is going to be wrong. So just make sure that you are notating this correctly. Percents that are close to 100 are more likely to happen, with 100% being guaranteed to happen, and percents closer to 0 are less likely to happen. So a 5% chance is not very likely to happen. A 0% chance means it's impossible for it to happen. All right, so there was a lot of questions on the questions that have to do with the simulations. So let's go ahead and review a simulation problem. So let's say that we have a certain person who is going to play a game, okay? And so maybe it's like a claw game. And maybe 30% of the time he wins a toy. And so that means that 70% of the time he does not win anything. So you know the game that you put a quarter in and you have that big claw and you can reach down and grab like a stuffed animal or candy or something like that. So let's say he's pretty good, because 30% is kind of good for something like that. And we're going to say what is the probability he will win at least 2 times out of 5. And then I might say run 5 simulations. And after you run your 5 simulations, then you're going to give me the actual probability that you calculated. You never want to just do one simulation, which is why I took off so much points on the homework from 7.1 or 2, wherever we talked about simulations. Because so many of you just did one trial and that was it, and that's not enough. You have to do more than one trial. So our assumptions, first of all, and I cannot make this clear enough, the assumptions are not a sentence answer. Basically, it's just what you were told. It is that 30% win and 70% lose or do not win. That comes straight from the problem. So everybody should get part 1 right on the assumptions. All right, assign digits. The assigning digits has to come from your percent winning and losing. So if I'm going to assign between 0 and 9, 30% would be 3 numbers. So I would say maybe 0, 1, and 2 mean I win. And then 70 or 7 numbers out of these 10 numbers would be a loss. So maybe 3 through 9 is when you lose. That's all you have to do with the assigned digits. You have to make sure that this is the same percentage as this. So 0, 1, and 2 out of 10 numbers is 30%. 3, 4, 5, 6, 7, 8, 9, that is 7 numbers out of 10. That is 70%. All right, so our simulation now comes from using a random number table or using a random on your computer or your calculator. So what I'm going to do is I'm going to use a random number table, and I'm going to start at line 126. And remember, I am trying to do 2 successes out of 5 tries. So I'm going to pull 5 numbers at a time. 1, 2, 3, 4, 5. And I'm going to stop and see if I got at least 2. If I do, I'm going to put a check mark. If I don't, I put an X. So on line 126, the first numbers I pull are 9, 6, 9, 2, 7. Well, 9 is a loss, 6 is a loss, 9 is a loss, 2 he wins, but 7 he loses. So did he win what I asked him to win? 2 times out of 5? No, he only won 1 times out of 5, so this is a failure. I pull the next 5 numbers. This is now my second trial. 1, 9, 9, 3, 1. That is a success. 9 fails, 9 fails, 3 fails, and 1 is a success. Did I get 2 times out of the 5? Yes, there's 1 and there's 2. This is a success. That is trial number 2, and remember I want 5 simulations. The next 5 numbers are 3, 6, 8, 0, 9. 3 is a loss, 6 is a loss, 8 is a loss, 0 is a win, 9's a loss. Once again, did I get 2 out of the 5? No. So this is a failure. Next one, 7, 4, 1, 9, 2. That's a win. That's a win. So this is another win. All right, and my last set of numbers, 7, 7, 5, 6, 7. None of those won, so it's another failure. All right, so that was step 1 is the assumptions, step 2 is the assigning digits, and step 3 is the simulation. Step 4 is to write the conclusion, okay? So I look at those values that I came up with, and I got 2 check marks out of 5, and I put this in my calculator. So 20, 40, that's going to be 40% of the time. We won 2 or more times. So my answer kind of goes back to the problem. What were we talking about? Well, it was a claw game, and we were trying to win 2 or more at times, and then we ran our simulation. Okay, so that is how you do a simulation problem. This is how you get full credit. I need the assumptions, I need the assigned digits, and then I need you to do the set number of trials. Here is the 5 trials that I say. You can usually do 5 trials, 10 trials, 15 trials, somewhere along there. If it doesn't say how many simulations you should run, you better at least run 5, maybe more. And so as long as you did your simulations correctly, you're not going to get penalized if you've done 5 or more. But you will get penalized if you just do 1 trial, because if you do 1 trial, the first time we did it, we got an X. Well, 0 out of 1 is a 0%. Is 0% fair? No, because look at our simulation. We actually ended up with 40%. And the other could have been true. If I did this one first, I would have got 1 out of 1, 100%. 1 trial is never enough. So with these, you have to do several trials. So hopefully that helps clear up some questions. All right. Some other things that you need to be able to do in this chapter is to be able to read two-way tables. And those are ones where you had some variables going this way. So maybe A and B going this way because I'm not feeling creative, and C and D going this way. And then we know at the bottom it's going to be the totals. So maybe 10 are here and 20 are here, and so that makes 30. And maybe 25 are here, so that makes 35. And maybe 10 are here, that makes 30, and that makes 35. And so it's 65 total, because both of these should add up to 65. All right, so then we can just start asking some questions. If I said, what's the probability of A? We take the total number of A's out of everybody, and we get 65. I can ask you to do an intersection of the two. So B intersect D. That's the overlap of B and D. So B and D overlap right here at 10. So it's also 10 out of 65. I can ask you about the union. So what if I said D union A? So that's everything in D and everything in A, but we don't want to count A twice, or this right here. So we just add up these 3 values. So 20, 30, 45, still out of 65. So those are those different values. Maybe I could even ask about a complement. So maybe I just say, what is not in D, basically. So everything not in D, D is this one. So everything else in D would be those right there. So 10 plus 20 is 30 out of 65. All right, well, you also need to be able to do conditional probability. So I may ask you, what is the probability of A given C? Okay, and we said that the probability on bottom is just going to be the probability of all of C, and the probability on top is going to be A intersect C. So when I work on that one, A intersect C is the A and C intersecting, which is 10. And the probability of C is everybody in C, which is 30. Remember when you see this little slash line here, the denominator changes. It's no longer the biggest number that we get. That's usually what we did with at the beginning of this chapter. But in section 3, we started talking about conditional probability, and your denominator is actually going to change. So just make sure that you review through that and that you feel confident with the different values of conditional probabilities. All right, so some terminology you should know. You should definitely know independence and the formulas that go along with it. You should know about mutually exclusive. You should remember complement. And that was one of the questions I asked you on one of your homeworks, was if mutually exclusive means a complement or if complement means a mutually exclusive. So you want to make sure you review through those. Any other terms that I mentioned in the chapter, you want to make sure you're familiar with them. Definitely the symbols, you need to know what intersect and union mean, and the complement. You need to be able to read Venn diagrams. Venn diagrams, you need to be able to find the probability of those. All right, after that, you need to be able to build a tree diagram from given data. And as you're reading the given data, remember that you have a branch that starts here, and this is your first roll or your first trial or whatever. And then on your second trial, if the events are independent, meaning like I flipped a coin, this would be 1/2 and this would be 1/2, and nothing changes between the first and second. But if it is not independent, and that means I'm actually pulling something out, so say like the probability that I get a red M&M or not, maybe the first time my probability was like 3 out of 20, but once I eat one of the red M&Ms, now my probability, I could go to red or not again for my second draw. But now if I eat one of the red M&Ms, it's now 2 out of 19. And then not would be 17 out of 19. That's a 19. Anyway, so that's how we set up those. And remember, if I said what's the probability that I got a red, we multiply branches. So I would do 3 over 20 times 2 out of 19, and we would multiply straight across, and then we would change it to a decimal. And I don't have my calculator out, so I won't actually work this out. But you want to feel comfortable setting up these tree diagrams and then actually calculating what it says. Remember, if it asks you about more than 2 branches, like what if it said, what's the probability that you get red, or not red, not red? In something like this, you would put your first answer in parentheses that is multiplied together, and you would add it to this one's probability multiplied together. And so that's how you do stuff like that. So I won't do an example like that because in 7.3 I did several examples. So you can always go back to the videos. That's a nice thing about them being posted online is you can just go back and you can just figure it out. So I have one more question I wanted to do. And this is from your review assignment. So this is actually page 367. And it is number 86 in your book. So you can open your book to page 367 and follow along with me, because I'm going to show you how to set up another tree diagram one that doesn't have like marbles or dice or whatever, which I think are easy, but it gives you data, and that makes it a little bit hard to set up. So 86, a boy uses a homemade metal detector to look for valuable metal objects on the beach. The machine isn't perfect. It identifies only 98% of the metal objects over which it passes, and it identifies 4% of the non-metallic objects over which it passes. Suppose that 25% of the objects that the machine passes over are metal. Find the probability the boy has found a metal object when he reaches a signal from his machine. And we want to show work. Okay, so we're going to start with the most important information, is whether he found a metal piece or not. So our first branches are metal or not. They told us that he is going to get metal about 25% of the time, so we're going to put 0.25 on this branch. And even though they don't tell us how much are not metal, we can add up to 100 and find out, well, if I have 1/4, 3/4 have to equal $1 more. So 75% are not metal. All right, so now your metal detector is either going to buzz or it's not when it finds a metal piece. So if it is a metal and the machine buzzes, that means it's being effective. It's actually identifying a piece of metal that it is. It could go over the metal and not make a sound at all, in which case it's not being effective because you passed right over metal, and it could have been a really rare piece of metal and really worth a lot of money, and it didn't even go off. Okay, so it told us in the problem that it only identifies 98% of the objects that it passes that are metal. So it actually buzzes when it says identify. That's what it's talking about, 98% of the time. And then remember, it has to add up to 100%. So that means that 0.02, because 98.02 is 100, would not buzz. Then when we look at the second situation, if the metal, if it's running over something that is not metal, it could actually buzz and make you think that you found something metal even though it's not, or it could correctly not buzz when it was not metal to start with. Okay, it says that it actually buzzes 4% of the time. We write that as 0.04. And once again, they don't tell us, but 96% plus 4% would be 100%. So that means this would be 96. All right, so first of all, to answer this question, we have to find the probability that it's actually going to buzz. There are two tracks where that will happen. It could be this one, or it could be this one. So any one that ends in buzz is the one we're interested in. So the first one is going to be 0.25 times 0.98, and we're going to put a plus sign in between it, and then we're going to go this track, which is 75 and 04. So 0.75 times 0.04, and we plug that into our calculator, and I get that that's 0.275. Now, I'm also interested in finding the probability that it is metal and it buzzed. That is a correct identification because it was metal and it did go off. Okay? Well, the metal buzz is the 25 and 98. So we just do 25 or 0.25 times 0.98. And that is going to be 0.245. So what we're actually trying to find, because the question said, find the probability the boy has found a metal object when he receives a signal from the machine or he hears a buzz. So we're trying to find the probability of its metal given that the machine buzzed. And we know what that probability is because that's one of our rules. It is probability of metal and buzz over probability of buzz, which is what I calculated up here, and that's why I did it. Okay, so probability of buzz is usually going to be the addition of something, and it needs to always be the bigger number, because if you put a bigger number on top, you're going to get a percent over 100, and we can't have that. And then this one right here, metal and buzz, the intersection of those is 0.245. We plug this into our calculator and multiply by 100, and we get that that happens 89% of the time. Now, like I said, there will be a test question that's very similar to something like this. So when you go home and start studying for your test, I recommend that you read through number 86 again and try to set it up. And if you can't set it up, come back to the video and look over this part and see if you can figure out where you got confused or where you got messed up. The problem with these word problems is they don't normally go in order, or they don't always go in order. So you saw that 25% are metal was the very last thing they told us before the question, and it actually ended up being what we needed to do first. So when you do these tree diagrams, it's more important if something is metal than the machine buzzes, because it was metal long before my machine buzzed. So we kind of need to think in chronological order. What needed to happen first? That it's metal or not, or that our machine buzzed or not. It's kind of cause or effect. This needs to come before the buzz, because the buzz should be caused because of the metal. So it should always work like that in a tree diagram. Okay, so as my new policy, you can't resubmit homeworks. And so what I've just decided to do is that I will always assign a review assignment at the end of the chapter. And if your review assignment is good and you submit it, I will replace your lowest homework grade from that chapter. Or if you have a missing grade, I will replace that grade with something, with the grade that I would give you for this. My reason being is because if you know the review material, then you obviously knew the old stuff, even though you may not have known it at the time. Okay, so as long as you're learning, that's what I'm wanting to see. So I will give you a review assignment, and I want you to work on it whether you submit it or not. So this assignment is optional, but not. It's optional in that you don't have to turn it in for a grade if all of your grades are good, but you do need to try it, because these review problems are meant to help you get you ready for your test. So do sit down and start working through some of them. And if you know you don't want to turn it in, maybe you don't have to do all of them, but you can look over them and make sure that you understand. If you still have questions as you're working through, you want to make sure you're asking them and getting help so that you can be well prepared for the test.